Hello, my name is Hannah Armstrong, and I'm a rising sophomore in the Honors Biomedical Engineering program. The title of my work is Determining Necessary Foot Coverage of Shoe Insole Smart Sensors for Accurate Force Readings. Ground reaction forces, or GRF, is the most valuable information in biomechanical analysis, but it only has one viable method for data collection, that is, force plates. Due to expense and lack of mobility, wearable technology has been investigated in other studies like my own. Prior work has demonstrated a novel carbon nanotube-based pressure sensor to be reliable in measuring GRF. The question I'm aiming to answer is, can we get accurate GRFs with 2 or 3 sensors located at the bottom of the foot? To answer this question, 2 conditions were tested as seen in Figure 1. A shows the whole foot being covered with sensors covering the toe, midfoot, and heel regions, and condition B being only the toe and heel regions being covered. Briefly, to make the sensors, we selected a common shoe size, printed sensors with the desired shape and size, connected the sensor to an Arduino, which streamed data to a spreadsheet. We recruited 3 subjects to participate in this pilot study. Collecting data for each condition was done simultaneously as the participant wore a shoe insole that held the 3 sensors while walking for a minute at a comfortable walking speed. Data was collected on a force plate instrumented treadmill, which serves as the gold standard for GRF values. When processing the data prior to qualitative evaluations, the data was calibrated to each condition. The 2 sensor condition had the heel and toe sensors calibrated on a range of 0 to 100% body weight per subject. And the 3 sensor condition had the heel, midfoot, and toe sensors calibrated to 0 to 100% body weight per subject. When looking at Figure 2, we see GRF for 4 gait cycles, where 2 sensors are shown in dark blue and 3 sensors shown in green. It is apparent that both sensor conditions measured higher values than the golden standard force plates, this being in the graph, pun unintended, the color gold. In Figure 3, where the peak forces are being compared between each condition for 3 subjects, the pattern continues with each sensor set measuring higher and the 3 sensor set measuring the highest. These observations lead to the conclusion that further steps need to be made during the calibration stages to ensure that the measurements are not being exaggerated. These conclusions are being inferred due to the limitations of not being able to isolate the midfoot sensor when calibrating, inconsistencies with the board and percent change of the sensors, and also not being able to increase sensor sampling frequency. With these conclusions, the steps taken in the next few months will be to standardize the calibration steps more, complete statistical analysis, and improve hardware of software so that way we can accurately measure ground reaction forces using shoe insole smart sensors. Thank you for listening to my talk and have a good day.